Hi friends, welcome to EK Lectures. In this lecture, we are discussing the following questions from the physics question paper of Karnataka SET 2020. 48th question. Suppose we have two non-interacting identical bosons, both of the mass m in one-dimensional infinite square well potential of this is the range of the square well potential, and the wave function, you are asked to find out the wave function when one of them is, that is, one of the particle is in ground state and the another particle is in first excited state. Now see, this is the wave function of first excited state, this is ground state. Now what are the possible ways? Either the first particle is in the ground state and the second particle in the first excited state, or the first excited state is having the second particle and the ground state ground state is having the second particle and first excited state is having the first particle. So these are the only possibility. Okay, now so what is psi? Psi 1 is equal to under root 2 by length of the box. What is that? Is a sine of n pi x by a. Since it n equal to 1, pi x divided by a. This is psi 1. What is psi 2? Under root 2 by a sine n equal to 2. So 2 pi x divided by a. So this is psi 1 and psi 2. So here, since bosons are present, bosons, total psi is equal to symmetric. The total psi must be symmetric. That means a wave function psi has two forms. Either it is psi space or psi spin. Okay, together psi space and psi spin must be symmetric. That means if the psi space is symmetric, psi spin also must be symmetric. Or if psi space is negative, that means anti-symmetric, psi spin also must be anti-symmetric. So plus into plus you get plus, that is symmetric. Minus into minus you get plus, that is symmetric. That means together it must be symmetric. Now here the question is incomplete because one of the state must be given. One of the state of either psi space or psi spin must be given. Only then we can find out the other one. Now here psi spin must be given because whatever is in the option, it is about psi space. Okay, if the psi spin is symmetric, then your psi space also must be symmetric. Symmetric means you have to use this formula. If psi spin was anti-symmetric, that is minus, then your psi space must be again anti-symmetric. Okay, so then you have to use this formula. So here this is psi space plus, that is symmetric. This formula you have been using. This is for anti-symmetric. So it depends on the value of psi spin. If psi spin is symmetric, then your option is C. If psi spin is negative, then your option is D. Okay, so from this question we can't say, because either of this psi spin should have been given. So option, it is given in the answer key as C, but D is also possible answer depending on the psi spin. The partition function for a photon gas is given by log z is equal to pi square by 45 into V into kt whole cube divided by h cross cube c cube. The internal energy or the average energy. This internal energy is given by U is equal to minus dou by dou beta log z, or in terms of temperature kt squared into dou by dou t of log z, where beta is nothing but 1 by kbt. Kb is Boltzmann constant. Now, so here it is written given in terms of t. Our function log z is a function depending on t, so we can take the second equation. So u equal to kt squared into dou by dou t of log z. This together is given log z. Partition function is z. What you need in this equation is log z. So here log z is given. So log z is nothing but pi square divided by 45 into v into kt whole cube divided by h cross cube c cube. Now we can take all the constant outside. So kt squared into pi square divided by 45 vk cube divided by h cross cube c cube into dou by dou t of t cube. So that's equal to kt squared pi square divided by, this is 45 into vk cube divided by h cross cube c cube into 3t square. Alright, so here you have k, so k power 4, t power 4, so kt whole power 4. Okay, then pi square divided by this is 3 and this is 45, so that is 1 by 50, and we have pi squared, this is pi squared v by h cross cube c cube into v divided by h cross cube c cube. So your answer is T. Average energy of an ensemble of gas molecules in equilibrium is given in terms of partition function z by similar question. Internal energy is equal to U equal to, or sometimes it will be written as U bar to indicate average, minus dou by dou beta log z. This is in terms of beta. If your z is a function of beta, you can use this formula. Now suppose your z is a function of temperature, then use this formula. Now beta is equal to 1 by kbt. Now dou beta is nothing but minus 1 by kb t squared. Okay, so kb t squared into dou t. Now just substitute here dou beta here. What you are getting is, so let us substitute that minus dou by dou beta log z is equal to minus dou by, instead of dou beta we will write minus 1 divided by kb t squared into dou t. That is nothing but minus get cancelled, so kb t squared into dou by dou t. This is log z, here also So this is how you get uh, two different equations for internal energy. This is KB, Boltzmann constant.